Hello learners! Welcome to another day of learning and discoveries. Come and join me learn science and make it quick and easy. In this lesson, we're going to compare the different colors of light in terms of wavelength, frequency, and speed. To understand this better, we're going to define different terminologies. First one is wavelength. Wavelength is the distance between two consecutive crests or two consecutive troughs. Wavelength is the distance between two identical points. Let's say you started with the crest of a wave. Its wavelength is the distance between two consecutive or two successive crests. Or you could have point A to E for one wavelength. One wavelength is equal to one complete wave cycle. The frequency refers to how often a wave cycle passes a given point per second. From the figure, A to E is one cycle and E to I is another. Therefore, there are two wave cycles in a second, or two cycles per second. Now, let us compare the frequency of waves with different wavelengths. Try to see figure 2. Let's say, these are waves created for a period of 1 second. Every wave cycle is marked with a line in the figure. The blue wave is shorter wavelength and has 6 wave cycles. And on the other hand, red wave with longer wavelength has 3 cycles or 3 Hz. So for blue, we have 6 Hz or 6 cycles per second. For red, we have 3 cycles per second or 3 Hz. This only shows that the wavelength and frequency are inversely proportional. Visible light is a small section of the electromagnetic waves. It is visible to human beings. It is called visible because it activates our retina the moment they hit our eyes. The wavelengths longer than the red spectrum of light, like the infrared, and that region shorter than the wavelength of the violet spectrum, like the ultraviolet light, are not visible to the eyes, but are visible to other organisms because each organism has its own visible range. The bees, for example, can see ultraviolet light, while the snake can see infrared or heat rays. And since we are emitting heat rays, we are very much visible to the snakes. Each color that makes up visible light has different wavelengths and frequencies, but traveling at the same speed. From the figure on the visible spectrum of light, red light has the longest wavelength, while the violet spectrum of light has the shortest wavelength. The colors red, orange, yellow, green, blue, indigo, and violet are arranged in decreasing wavelengths, but in increasing frequency. But why are they traveling at the same speed? Any wavelength has its corresponding frequency, and any wavelength multiplied to its corresponding frequency will always give us the speed of light. Let us analyze the symbol here. As you can see, we're going to consider the wavelength and the frequency. In this kind of equation, for wave, for the wave speed, it is represented by V, while for the wavelength, it is represented by the lambda. On the contrary, we have F for the frequency. We're going to multiply the wavelength and frequency for us to get the speed of the light. How fast is the light moving? The speed of light was first calculated by the Danish astronomer named Ole Romer. According to him, the speed of light is about 299,752,458 meters per second, or approximately 300 million meters per second. We can also write it as 3 times 10 to the 8th power meter per second, and that is the speed of light in all wavelengths in a vacuum.